Hi, this section here is going to be 4, 5 multiplying mixed numbers. Write that down. 4, 5 multiplying mixed numbers. And with this, what works every time, and then we'll talk about a special case next, but what works every time is to change them to an improper fraction and then multiply numerators, multiply denominators. So change to improper. Sometimes those are called top-heavy fractions. And multiply, got distracted, multiply the numerators and denominators then change back to mixed fractions. Really, I should say to mixed numbers. Like I said, that will work every time. Kind of the exception to the rule, though, I'm going to kind of put that right in here, is let's say we have just a number times a mixed number. So the example I'm going to do soon down here is going to be 7 times 2 1/4. Or maybe I should show it this way first. So what I mean by this here, change to an improper fraction. If you're not sure how to do that, check back to an earlier section of the notes. I think it was 4-3. But what we're doing is we're saying, well, that's going to be 7 times. I do 2 times 4 gives me 8. So it's kind of like, that 2 is kind of like having an 8/4. But then I have this other 1/4 here. So I could take and change my 2 1/4 to 9/4. So now if I have 7 times that, you could always look at a fraction or a number as though this 7 here, that's really the same as like 7/1. So I'm going to take my 7 and look at that as though it's 7/1. And now, just like always when you multiply fractions, I tell my students it's kind of like you can just extend the line really and treat it like one big fraction. And now we have 7 times 9, or 63/4. And now that we do this, you could look and see, could I reduce first? In this case we can't. We say, well, how many times does 4 go into 63? Well, 10 times would get me 40, so 60 is half of that again, so it would be 15. So this would be 15, which would be the same as 60/4 and 3/4. So that's going to be the final answer then, is 15 3/4. So that's one way to do it. If though, and that's going to be the way that you do it whenever you have a fraction times a fraction. Computer's going a little screwy there. But let's say we have the exceptional case here where we have a number times a fraction. What you could do there if you wanted to, I'll indent to say when, lost my pen. So when multiplying a number times a mixed number, multiply the number by the whole number, and by that, for this example, what I mean is do the 7 times the 2 and the number times the fraction, which would be the 7 times the 1/4 times the fraction, and recombine. Push comes to shove, if you just want to be able to get the thing done, you could go with the way we did it before. That'll work every time. But if you want to take the little shortcut, this would be the shortcut. And essentially what we're doing is we're looking at it as though it's a distributive problem. So I have 7 times 2 1/4. I'm really looking at it this way. I'm really saying that this here is the same as 2 1/4 is really 2 plus 1/4. But that's all that fraction, that one number. Now that I have my 7 there, I'm really just doing distributive. I have my 7 times my 2, and I have my 7 times my 1/4. So when I do that, 7 times 2 gets me 14, which you'll notice is different. Before we ended up with 13, or 15, but 7 times 2 is 14. Now I have 7 times 1/4, which we'll kind of write it out like before. I had 7 over 1, well, it's going to be plus. If you do distributive, it'll be the plus because I have a positive times a positive. But 7 over 1 times 1 over 4, which now let me scroll down a little bit here, is going to give me 14 still, plus 7 over 4. Now I can take my 7 over 4, I need to change that back to a mixed number. 4 can go into 7 once, and that will take out 4 of my 7 up in the numerator. So then I have 3 left. So my 7/4 becomes 1 3/4. I have 14 plus that for that same final answer of 15. 14 plus 1 is 15 3/4. Okay, so that's kind of the way that'll work every time, and I'll do a couple more examples of that. And this here would be the example of a little bit of a shortcut you could do if you have a number times a mixed number. But if we go back now, and if we have just a couple more examples, if I have, we'll say 4 3/8 times 2 1/7. Now it's tempting to take that shortcut and just do my 4 times 2 and my 3/8 times 1/7. That's not going to work. And that if you were to try to do that, it's something that you'll get to later on probably. I don't think you've done it already, but where you have to FOIL. So I wouldn't write this. But when you have a problem like that, it's really you need to do distributive twice. You'd have to do the 4 times the 2 and also the 4 times the 1/7. You have to do the 3/8 times the 1/7, but also the 3/8 times the 2. You have to do both of the first parts times both of the second parts. So that ends up being probably more work than just going through and changing them to improper fractions. So if we take this number here, I have my 4 times 8, which is 32, plus 3 gets me 35 over 8, times 2 times 7 is 14, plus 1 is 15. And again, the notes, chapter 4, section 3, I believe, go over doing this, part A. Now we take and we multiply those two together. So we could just look at it right away as being one line and multiply and multiply. We're going to get some pretty big numbers. So instead, what's smart to do is go through and say, well, what can I reduce? Well, 7 and 35 are both divisible by 7. So I'm going to divide this by 7 and get a 5. Divide this by 7 and get a 1. And now the problem becomes a whole lot easier. I don't need to get out my calculator, because I'd have 5 times 15 is going to be 75 over 8. Then from there you could look at, could I reduce even before I change it back to a mixed number? And divisible by 2, but that's not. This would be divisible by 3, but that's not. So as you go through, you're not going to find a number that works. So instead then you say, well, 8 goes into 75 how many times? And 75 is a little bit bigger than 72, which is 8 times 9. So I could say 9. That's going to get rid of 72 of my 75, which leaves me then 3 left. So, and it's good to check and see if that's reducible, but if it wasn't before, it won't be now. So 9 3/8 is going to be the final answer for that one. And do one more example, and then I am done. So my last example, say, is 5 1/2 times 4 7/9. So first step, change those to improper fractions. So 5 times 2 is 10, plus 1 is me 11 over 2. And then I have 4 times 9 for a 36, plus 7 more is going to be 43 over 9. Ooh, I was really hoping that that would be reducible. Let's take a look at it. It is not. Checking my math. Yeah, it is not. Ooh. Okay, so 11 times 43, that's going to be saying like a 43 and a 43. You're trying to do that in your head. So 11 times 43 is going to be 473, all over 18. And now, if you have a calculator, you can pull that out, but I know I'm telling my students they can't do it with a calculator. So this won't be reducible because the number before wasn't. So we're really stuck going back to 473 divided by 18. And if we do the math here, so if I double 18, so 18 times 2 is going to be a 36. So 36 right there. Do my subtraction, I get 11, and I have to pull down my 13. Let's see, so I think I can do about 3 of these. So I want to say 18 times 6, so I'd have 48, and then I'd have 6 plus another 4 is 10. Yep, so 108. So 108 with 5 left once I subtract. So from there then we could say, all right, this here, it comes out to be a whole 26. So I have 26. And then when I do 26 times 18, that's going to give me a remainder of 5. So I'd have 5/18ths left. And if it wasn't reducible before, it won't be reducible now. That's all from this section. Let me know if you have questions.